Hello viewers, I am Dr. Mala Das Sharma, retired professor of St. Pius 10th degree and PG College for Women, Hyderabad. Welcome to my channel Chemphilic. Let's start the 29th episode of Teaching Chemistry through Riddle. Do watch the video till the end. So let's start riddle number 29. Mr. X is a compound with two different functional groups and an active site. The active part can easily form an intermediate which makes the compound highly important in synthesis organic chemistry. Compound X is born by the union of two same or different molecules of a specific derivative of carboxylic acid. Two different pathways are possible for the hydrolysis of Mr. X. One mode of hydrolysis leads to the formation of different ketones and diketones, while through other mode of hydrolysis, different monocarboxylic and dicarboxylic acids can be synthesized. So this is our riddle number 29, and now let's see the question. The question is, who is Mr. X? That means you have to identify Mr. X. Let's solve the riddle and identify Mr. X. The clues given in the riddle are, first one, Mr. X has two different functional groups and an active site. From the active site, a reactive intermediate is formed easily which enhances the synthesis ability of Mr. X. So, we can, from these two clues, we can guess Mr. X as ethyl acetoacetate. Now, we have to confirm it. So, Mr. X may be ethyl acetoacetate because in this molecule you have two functional group, one ketone group, one ester group, and the active site, that is active methylene group. Now let's confirm it with other clues. Mr. X is formed by the union of two same or different molecules of a specific acid derivative. Now, this ethyl acetoacetate is formed by Claisen condensation reaction. Now, Claisen condensation, it is a condensation between two ester molecules. Molecules may be same or different, but one condition, at least one ester must have alpha hydrogen atom. And this condensation takes place in presence of base, and the product is beta keto ester. Ethyl acetoacetate also a beta keto ester. Now, ethyl acetoacetate is formed by the Claisen condensation between two molecules of ethyl acetate, which is derivative of acid, and it has, that means ethyl acetate has alpha hydrogen atom, and the reaction takes place in presence of strong base sodium ethoxide. Let's see. Now here, from one molecule of ethyl acetate, carbanion is formed when it is treated with the strong base sodium ethoxide, and now this carbanion condenses with another molecule, and finally it forms the beta keto ester ethyl acetoacetate. This is alpha position, this is beta position, keto group is there. Now, another clue is two different pathways are possible for the hydrolysis of Mr. X. Now, acetoacetic ester and its mono and dialkyl derivative undergo two different hydrolysis reaction. That means two different pathways are possible. Number one, ketonic hydrolysis. In ketonic hydrolysis, the reagent is dilute aqueous alkali or acid. And here the products are ketones. Now let's see. This is ethyl acetoacetate. In ketonic hydrolysis, the cleavage takes place in this position. So from here, carbon dioxide is released. And on hydrolysis, this water molecule, hydrogen adds up to this carbon. So from here you will get acetone and OH group adds with this carbon. So from here you will get the ethanol. So the products are acetone, carbon dioxide and ethanol. And from this part you can synthesize different ketone compounds by using the suitable reagent. We will see that. Now, second mode of hydrolysis is acid hydrolysis. In acid hydrolysis, the reagent is concentrated alcoholic alkali, and obviously the products will be carboxylic acids. Now here, these cleavage positions are here, this part and this part. So, on hydrolysis, what happened? This OH group will attach to this carbon. So, from here you will get the acetic acid. And from here you will get the ethanol, and from this middle part also, if you don't give any other reagent, if you don't synthesize any other thing, here also you will get the acetic acid. And from this part only we can synthesize the other compounds. So, with concentrated alkali, the products are acetic acid and ethanol. So therefore, let's come back to the original question. Who is Mr. X? Now it is confirmed. Question answer is ethyl acetoacetate, this compound. Now, ethyl acetoacetate exists in two tautomeric form. One is keto form where ketone functional group is there. Another one is enol form where this alcohol functional group, that is OH group, is there, and there is carbon-carbon double bond is present. Now, these two isomers are interconvertible. That means dynamic equilibrium exists between them, and they are real. They have real existence. The tautomers can be isolated. They are not like the imaginary resonating structures. Okay. Now let's see. So this is the keto form, and after enolization, this is the enol form. And for ethyl acetoacetate, this enol form is stabilized through this hydrogen bonding. Now, this ethyl acetoacetate, we have seen that active methylene group is there. From there, easily carbanion can be generated, and this carbanion is also resonance stabilized. So this take part in resonance with this double bonded, this is carbonyl group. Okay, so it will come here, it will go, and then this will be the other resonating structures. Now, technique for synthesis from ethyl acetoacetate. Now, first one, synthesis of alkyl derivative of ethyl acetoacetate. So this is the active methylene group. From here, on treatment to strong base, you can remove the hydrogen and form the carbanion. Now, with this carbanion, when alkyl halides are treated, or when alkyl halides react, you will get the alkyl derivative. Say for this compound, two methyl groups are introduced. That means first you have to form the carbanion by using this sodium ethoxide, and then followed by methyl bromide. So one methyl group will be introduced. Repeat the same. Second methyl group will be introduced. Now this compound, here one is ethyl group, one is methyl group. After carbanion formation, you have to treat it with ethyl bromide. Then again you have to treat it with methyl bromide. So first with methyl bromide, second with after carbanion formation ethyl bromide. Now here similarly, first you have to treat it say ethyl propyl bromide or methyl bromide. Again you have to repeat it with the other alkyl group halide. Now let's see the synthesis now. Synthesis number 1. Synthesis of monoalkyl and dialkyl derivative of ethyl acetoacetate. So already I have told you there, after formation of carbanion with sodium ethoxide, so when it is treated with alkyl halide, then sodium bromide is removed and this alkyl group is added here. So this is the methyl group is added. Now this is monoalkyl derivative or monomethyl derivative. Once again repeat the same. Form the carbanion and treat it with methyl bromide. You will get dialkyl derivative of ethyl acetoacetate. Now synthesis number 2, synthesis of butyric acid. So this is ethyl acetoacetate. From here you have to prepare butyric acid. Now, so this is acid. So obviously you have to go for acid hydrolysis. Now for acid hydrolysis, this is the cleavage point. So this part is constant acetic acid, this part is constant ethanol, already I have told you. So we have to see this part. We can synthesize from this part in acid hydrolysis. Now compare this part with your product molecule. Look at here, CH2COOH, this part is already there. So just you have to add this ethyl group. Then you have to go for acid hydrolysis. So this is the pathway. So first this carbanion is formed and then sodium salt of this carbanion is present in the form of sodium salt. Now then with this carbanion, this ethyl bromide reacts and then ethyl group is introduced. Now this cleavage will be here for acid hydrolysis. You have to give the reagent for acid hydrolysis, which then you will get the butyric acid. Now synthesis number 3, synthesis of succinic acid, that is dicarboxylic acid. Now ethyl acetoacetate, from here you have to prepare succinic acid. We know the cleavage point. So if we compare this part with succinic acid, CH2COOH is already there. So I have to introduce another CH2COOH. Two methods are there. Either you can take the alpha halo ester, so that this CH2 group will introduced here, or you can use the 2 molecules of ethyl acetoacetate. Now let's see. First of all, you have to make the carbanion and treat it with this alpha halo ester and then followed by your acid hydrolysis, which is concentrated alkali. So same thing is happening here after introducing. Then now acid hydrolysis, cleavage will be here and then look at here, this part will be ethanol, this part will be acetic acid and in this part will become CH2COOH and already CH2CO, C2H5 is there. In presence of alkali it will become acid. So finally you will get the succinic acid. Now synthesis of succinic acid, once again alternative method, as I told you, you can take the 2 molecules of ethyl acetoacetate and with sodium ethoxide form the carbanions in both the molecules and treat it with iodine. So this part will be added up. Now do the acid hydrolysis by using concentrated potassium hydroxide or sodium hydroxide and then the breakage will be here. So from this part you are getting CH2COOH, CH2COOH, that is succinic acid. Now synthesis number 4, that is the synthesis of crotonic acid, which is alpha beta unsaturated acid. Now this is ethyl acetoacetate. From here you have to prepare crotonic acid, this one, which is alpha beta unsaturated acid. Now for acid hydrolysis we know the cleavage point. So this part is only in our hand. Now compare this part with this part. What you have to add? C. CH double bond COOH. CH COOH and double bonded CH. So this part we can get it from here. CH C double bond. This will become, we know that COOH. Okay. Now we have to add this part with double bond. Now the reagent is acetaldehyde and for acid hydrolysis concentrated alkali. Look at here. Now, when this ethyl acetoacetate is treated with acetaldehyde, this oxygen and 2 hydrogen removed as water, and this part, this carbon and this carbon, they join by double bond. So, C double bonded, then this CH and this CH3. Now go for acid hydrolysis. So, we know the cleavage point, and then acid hydrolysis, if it cleaved here, then what will be the compound? CH3, CH, double bond, CH. This part will become COOH. So, we are getting the crotonic acid. Now, synthesis number 5. Synthesis of acetyl acetone. So, this is ethyl acetoacetate. You have to prepare acetyl acetone. This is the acetone molecule. From acetone, one of this hydrogen atom is replaced by acetyl group, CH3CO group. So, this is acetyl acetone. Okay. Now, this is the ketone compound. So, we have to think about ketonic hydrolysis. And ketonic hydrolysis means this part is the breakage point. Carbon dioxide is released. So, whatever you can synthesize, you have to synthesize from this part. So, this part is in my hand and this is the product. So, compare this part with this product. See, CH3, C double bond O, CH2. This part is already there in my compound, in this molecule. What we have to add? CH3CO. So, the reagent is CH3COCl, acetyl chloride, and dilute aqueous alkali for ketonic hydrolysis. Let's see. So, what happened? You have to take acetyl chloride. Now, this hydrogen and this chlorine removed as HCl, and this compound is formed. Then, if you do this ketonic hydrolysis, you will see the breakage will be here, and then from this part carbon dioxide will remove, and from this part you will get the ethanol. And what is there? See, in this part on hydrolysis we will get CH3CO, CH2, CO, CH3. That means our acetyl acetone. Now, synthesis number 6, synthesis of acetonyl acetone. So, this is ethyl acetoacetate. From here, you have to prepare acetonyl acetone. That means here, this is one acetone molecule, this is another acetone molecule. These two carbon atoms of this acetone and this acetone, they are joined here. So, this is acetonyl acetone. Now, so this is ketones. So, you have to think about ketonic hydrolysis. Ketonic hydrolysis, this is the breakage point. Carbon dioxide will be removed. Now, compare this part. From here, you can do the synthesis. This part with your product. Now, look at here. CH3COCH2. Already one part is in my hand. So, exactly same part is required. So, you have to take 2 molecules of ethyl acetoacetate. So, the reagents will be, you have to prepare carbon ion, that's why sodium ethoxide, then iodine to join these 2 molecules, and then reagent dilute potassium hydroxide, that is for ketonic hydrolysis. So, here carbon ion is formed, then iodine, this part will be joined, and then cleavage for ketonic hydrolysis. After cleavage from this part, look at here, CH3CO, this part will be CH2, then CH2CO, CH3. So, acetonyl acetone. Synthesis number 7, synthesis of 2-pentanone. This is ethyl acetoacetate. From here, you have to prepare 2-pentanone. Now, for ketonic hydrolysis, this is the cleavage. So, compare this part with your product. CH3COCH2, CH3COCH2, already this part is already present in my ethyl acetoacetate molecule. So, we have to introduce only this ethyl group. Now, so the reagents are sodium ethoxide for carbon ion formation, ethyl bromide for introducing ethyl group, then dilute alkali for ketonic hydrolysis. So this carbon ion is formed, so ethyl bromide, then ethyl group is introduced, and then your ketonic hydrolysis, we know the cleavage, and then after that it forms the 2-pentanone. Now synthesis number 8, synthesis of 3-methyl-2-pentanone. So from this compound you have to prepare this. Now this is the cleavage point we know, and compare this part with this part. What is there? CH3 C double bond O CH2. This part is already CH3 C double bond O CH2. This part is already there in my compound. Now compare here CH3 C double bond O CH. That means you have to introduce this methyl group and this ethyl group. So use sodium ethoxide for carbon ion formation, methyl bromide for introducing methyl group, you will get this compound. Repeat the same thing, prepare carbon ion, now use this ethyl bromide and introduce this ethyl group. Now do this as ketonic hydrolysis by using dilute potassium hydroxide. So this is the cleavage point and your compound is ready. So CH3 CH2, then this is another CH3 molecule, CH3 group, and then C double bond O CH3, that is 3-methyl-2-pentanone. So we have come to the end of this video. Thank you.